Hello everyone, in this video I am going to discuss about the regulation of glycogenolysis and glycogenesis. In the first half I will be explaining about the regulation of glycogenolysis. So let's start the video. The key regulatory enzyme involved in glycogenolysis is glycogen phosphorylase. Now we know there are two types of hormone, that is glucagon and epinephrine, and both are involved in promoting glycogenolysis. Glucagon, it acts mainly on liver, whereas epinephrine, it can act both on muscle as well as in liver. Now both these two hormones bind to cell surface receptor, that is GPCR, and with the help of cell signaling it leads to the formation of CAMP, that is cyclic AMP, cyclic adenosine monophosphate. Now CAMP in turn activates pKa, that is protein kinase A. Now in the left hand side I have explained about how glucagon and epinephrine promotes glycogenolysis. So pKa, it activates glycogen phosphorylase kinase by phosphorylating this molecule. Now it is activated. So the P indicates it is phosphorylated, and here ATP is converted to ADP. Now the activated glycogen phosphorylase kinase in turn phosphorylates glycogen phosphorylase B. Here B indicates that this molecule is in inactive state. Now after phosphorylation, glycogen phosphorylase B becomes GPA. A indicates active state. Now this active form of molecule can convert glycogen to glucose 1-phosphate, and therefore in this way glycogenolysis will continue. Now in the right hand side, how glucagon and epinephrine inhibits glycogenesis. So pKa, it phosphorylates glycogen synthase A, which was initially active, but the phosphorylation of this molecule makes it inactive, that is glycogen synthase B. Now glycogen synthase in its inactive form cannot convert glucose to glycogen. So this was all about regulation of glycogenolysis. Now in this half I'll be explaining about the regulation of glycogenesis. The key regulatory enzyme involved in glycogenesis is glycogen synthase. So the main hormone is insulin. So insulin promotes glycogenesis. Insulin, it initially binds to cell surface receptor and activates protein kinase B, that is PKB. Now you can notice that in case of glucagon and epinephrine it was pKa, whereas in case of insulin it is pKb. Now in the left hand side, how insulin promotes glycogenesis. So the pKb, it phosphorylates glycogen synthase kinase 3, which was initially active, and it is known as GSK3 in short, but the phosphorylation of this molecule makes it inactive. So normally when GSK3 was active, it can inhibit glycogen synthase by phosphorylating it, but after the phosphorylation of GSK3 it became inactive, and therefore glycogen synthase remains active, promoting glycogenesis. Now pKb, it also activates protein phosphatase 1, that is PP1. Now PP1, it dephosphorylates the glycogen synthase B, which was initially inactive, but after dephosphorylation it became active, glycogen synthase A. Now this active form of the molecule can easily convert glucose to glycogen. Here in the right hand side I have explained how insulin inhibits glycogenesis. So the PP1, that is protein phosphatase 1, it dephosphorylates glycogen phosphorylase and makes it inactive. So here GPA, it was initially active, but after dephosphorylation it became inactive. So the inactive form of this glycogen phosphorylase cannot lead to the breakdown of glycogen to glucose. Now in summary, glycogen phosphorylase B, it was initially inactive, but epinephrine and glucagon phosphorylated it, and therefore it is converted into active form, that is GPA. Now this GPA can be again converted into its inactive form by protein phosphatase 1 with the release of inorganic phosphate, and protein phosphatase 1 is stimulated by the hormone insulin. Here glycogen synthase, it is phosphorylated and initially it is inactive, but insulin stimulates protein phosphatase 1 and leads to the conversion of this phosphorylated glycogen synthase into dephosphorylated glycogen synthase, that is glycogen synthase A. Now it is active. Now glucagon and epinephrine can again convert this active form of the molecule into inactive form. So this was all about the regulation of glycogenolysis and glycogenesis. Do consider giving it a like if you have grasped the concept well, and please let me know in the comments about any kind of improvements. Thank you.